Hi, hello everyone. This is John from Melbourne Polytechnic, and this is the subject bit362 digital forensic. And so today we are here to do a project to about the assessment too. So first of all, what we have to do in this assessment is we have to uh, investigate the hashing of foreign ties technology. So what we have to do in the first part A, we have to do is convert our student number to md5 hash. So what we have to do is, first of all, we use the window PowerShell, and we just select our command and to type the student ID and convert to the HD5 hash file documents in a notepad. So after the PowerShell has been hashed the file, and this bit of number is our HDI5 hash. So what we have to do is we have to save it. So we just create a file and to save it in here. So for in here, we'll just do it from student underscore hd5.txt. So this is the hd5 hash of this file. So next step, what we have to do is we have to hash the file. So to hash the file, we have to do the command in the PowerShell. So the PowerShell command will be here. So you can see this number right here shows in the column. It's the hash file number. So the difference is between why there will be like a difference hash numbers in the ID and the file. That is because if you hash the numbers, probably it will just hash the string. For example, like the S, 1 or 2. So that's why it's based on the characters that we type in the memory. But if we do it in the hash file, it's based on those characters that we stored in the disk, in the hidden extra. So that's why there are difference, like before hash it in a file and hash it individually. So now what we have to do is we try to do it like a baseline hash. So we just do another command in the PowerShell. We just do this. So we can see, like, after we do the baseline hash, there's no changes in the hash file. So now we can do the other testing. It's like we change the file attributes to read only and hidden. So first of all, we just select our file and just goes to the properties, and we change it to read only and just applied it. And after that, we're gonna do the hash again. See is there any changes. So we just run the hash in the PowerShell. So after we run it, it's still in the same hash. So because read-only is just a metadata stored in the file system, but it's not inside the file context, so that's why the hash didn't been changed. So now we try to change the permissions of the control. So we just goes to the file again. We just goes to the property. Then we get into the security. So we just goes to the user and edit our permissions like read only and applied. And after that, we try to do the same hash again. So we can see, like, even we change the permissions, the hash file number, it doesn't change at all. So next step, what we have to demonstrate is we rename the file extension. So for example, the file is called hdfile.txt, and we will change it to exe execute, and we'll hash it again and see what it happens. Now we just get back to the file and we try to rename it. and we rename it from txt to exe. Yep, after that we're gonna hash this file again. So finally we can't hash the we're gonna hash it to not txt to exe. So finally there's no change in the hash file as well, and the reason is because the name of the extension isn't inside the file what it is include inside, so that's why it's only affect when how Windows recognize the file. And finally we will try to email this file to ourselves, and we will hash the email file. So what I've done before is I'll send the email and download it, and after I download it, it will show it on here, student md5 from email.txt. So this time we will hash the email file, see is there any difference. So now we're gonna hash it, and we'll see it in PowerShell. So furthermore, it still shows that our hash files are in the same hash. So the reason is because the email sends the end code but restored in the same bytes on the download. So probably the name is different, but the intents inside it's all the same. So now what we have to do next is we try to add spaces at the file, and we will hash this file again. So now we're gonna hash, we'll just change it back to txt, and we open the file and we just add 2 spaces on it. After that we'll save the file, yes. Oh, we have to change it back, not read only, sorry. Get back to the properties, we just untick it, edit, untick it, applied. Okay, so now it should be okay now. So now we open it back again and save the file with adding 2 spaces and close it again. Now we can try to just use PowerShell to hash this file again. Yep. So after we add 2 spaces, the md5 hash has been changed to a different name and the different process. And the reason is because once you have added the files inside has been changed it. So that's why once when we add it, the result has been different. So now we just open the pad again, and we do something back to before. So we just delete these 2 spaces again. So let's see will there any change. So now we get back to the hash. We'll just open it back. Yep, we just delete that 2 spaces and save it again. So now we can hash the file again, and we can see the result. It's got no change, it's back to normal before. And the reason is because md5 is a deterministic for in the initial contents. So once we get back to the baseline, everything will get back to normal. So now, after we do this testing, we will use autopsy to do the recovery. So first of all, what we have to do is we have to delete the file and goes to the recycle bin. Because what I'm doing the process that we have done in AutoSeed, I didn't use a VM. I just used my PC hard disk. So that's why it takes a bit time to do a full scanning. But here of all, I can show the result is after I do the AutoSeed, and we can full scanning all the files. We can see like the files that I deleted before in delete files, and I can check in the plain text. So it's right here. So after I do it, I can extract the files, extract it back to the original folder. So here is how we do in AutoSeed. Like first of all, we create a new case. Then we have to put our data source. For example, in this case, my data source is my C drive. And after all, he will run the full scan, and he will find back the deleting files. And you can extract it back and recover it. So this is the recovery sections in the assessment that we have to do. And finally, we have done also in the PowerShell to repeat download the file in and capture in the Wireshark and double check the packets. So what we can see in the Wireshark. So before we do this, actually, in my case, I have to run PowerShell in administrator mode to reset the firewall rules to allow the port 8000 to be opened. So therefore, it has shows that I'm able to allow to do the captures on the HTTP in my port 8000. So what I've done in the Wireshark is, first of all, I've captured the port 8000, and then I use PowerShells to repeat download the files 10 times. So what we saw it like, we can see like in here, it's all the ACK and systems, and for this txt file and syn file, the three-way handshakings. So we can see all the packets through the Wireshark, and it also shows like all the hashes as well. So finally, in this demonstration, what we have seen in the Wireshark is the capture of the Wireshark that shows the TCP handshake of HTTP, which get 200 OK, which means like have download and exchange between the PowerShell client in the local server. So this confirms that the file transfer occurred, and it can be used as a forensic evidence of the communication. And about the hash packets, does it changes? Yes, it is, because in Wireshark, each network packet has their headers, like for example the Ethernet, the IP, the TCP, and the payload. So when calculate the packets which capture itself, the hash will change every time when we capture it again. So even though it's in the same time download. So in this demonstration, yes, the packets has been changed in each capture. So the second of the captured content, the hash of the contents that we download, because a file student md5 text, it's a payload inside of the HTTP response. So even though if we extract the payload and compute it is checked, as long as the files doesn't change anything inside, the hash file also will stay indential. So that's why we use hashes in forensics. They prove file integrity regardless how many times that we transfer and capture. So the result in this demonstration, the answer is no. Content hash doesn't have change unless the file of itself is there any changes. But if there's nothing changes inside the file by itself, there's nothing changed in the content. So finally, the hash of the packets captures in Wireshark changes because its transmissions have unique metadata like timestamp, sequence number. But however, the hash of the file content, for example, a student underscore md5 txt, it still remains the constants. So that's why I can confirm the file integrity across transfer. There's no change. So that's all for the part A demonstration, and thank you.